Welcome back everyone to another lesson of fractions with me, Mr. Duclos of Citizenship Academy. Today, we are going to decompose fractions using area model to find equivalence. Let's jump right on in. So in front of us, we have 4 different fractions. And we're going to do some review here, and we're going to quickly go over the area model. The area model means that we are showing our fraction in an area form, in some sort of grid fashion. So, we'll have our area, and the denominator is how many parts of the whole there are altogether. So altogether there are 3. So we're going to have 3 parts. Now a mistake I've seen some people make is that they see this 3 and they draw 3 lines. 1, 2, 3. But that's not right. That gives us 1, 2, 3, 4 as our total, and our total needs to be 3. So always make sure you're counting. So I have 2, now I have 3. Then I'm going to shade in the parts. The parts are the numerator. We have 1/3. Then we have 3 over 4. So again, I'm not going to do 4 lines, because if I do 4 lines, I actually get 5 parts. 1, 2, 3, 4, 5. And I need there to be 4. So here's our diagram. We have 1, 2, 3, 4 parts, and we need to shade in 3 of them. 1, 2, 3. This is 5 over 7. Make that 7 a little more crisp. 5 over 7. So we have our... And I'm just going to go the other way this time, just to show you, but you can draw it however you see it best. We'll go 1, 2, 3, 4, 5, 6, and that's going to give me 1, 2, 3, 4, 5, 6, 7. And then how many am I shading in? 5, the numerator. 1, 2, 3, 4, and 5. And then the last one, we have 2 over 5. One, 2, 3, 4, 5. And we're shading in 2 of them. So here are 4 representations of fractions using the area model. Now we're going to use the area model to find equivalent fractions. So right here I have 2 area models that, although I drew them different sizes, represent the same thing. I'm going to shade them both in the same. I'm going to shade them both in as 2. All right, I'll just restart that. So right here I have 2 area models that, although I drew them different sizes, they represent the same thing. They're both 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And they both have 2 shaded in. So they both represent 2 over 5. And we're going to use the area model here to show that some other fractions can be equivalent or equal to 2/5. So what I'm going to do is I'm going to take my 2/5, and I'm going to put a line through it. That's the same thing as doubling the amount of total parts. So now instead of 5, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 1, 2, 3, 4 shaded in. So that means that 4/10 is equal to 2/5. Over here, I'm going to take my 2/5 and I'm going to put 2 lines in front of it. And that's the same thing as tripling it or multiplying it by 3. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 as my denominator. And as my numerator, I have 1, 2, 3, 4, 5, 6. And that means that 6/15 is equal to 2/5. But I'm going to go one step further. I'm going to put one more through. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is my denominator. And 1, 2, 3, 4, 5, 6, 7, 8 as my numerator. And that means that those equal each other too. And I could keep doing that forever and ever and ever. They're always going to equal the same thing. Or they're going to be, not going to equal the same thing. They're going to be equivalent, meaning that they're equal in a sort of way. They represent the same thing as in terms of fractions. All right, now we're going to use this area model to look at two fractions and prove that they are equivalent. So here I have two fractions that I'm saying are equivalent. I'm saying that 3/4 is equivalent to 6/8. And I'm also saying that 2/6 is equivalent to 8/24. We're now going to prove that I'm saying something that's correct, that I'm right, using the area model. So the first thing I'm going to do is draw my 3/4. One, 2, 3, 4. I always make sure to count. And I'm going to shade in 3 of them. 1, 2, 3. Then I'm looking at my problem here, and I'm seeing that in the denominator, 4 is twice as less than 8, or 8 is twice as more than 4, right? 4 times 2 is equal to 8. So that should mean that if I take my graph here and I multiply it by 2, I get 8. 1, 2, 3, 4, 5, 6, 7, 8. I do. And I should have 6 colored in. 1, 2, 3, 4, 5, 6. I do. So I've just proven that 3/4 is equal to 6/8 using the area model. Let's do one more. So this one is a little bit of a bigger problem, but the process is the exact same. So let's give it a go. We have 2/6 and 8/4. So I'm going to draw my 2/6. I'm going to do it this way this time. One, 2, 3, 4, 5. I need one more. I can draw it like that. 6. 1, 2, 3, 4, 5, 6. And how many am I shading in? 2. One and 2. So now I need to find a way to prove through my graph that this is true, that 2/6 is equal to 8/24. Well, if I look closely, I'll notice that 2 times 4 is 8, and 6 times 4 is 24. So, if I cut it by 4, that should work. Multiply it by 4. So, I'm going to create 1, 2, and 3. And remember, it's the same thing. I need to cut it up into 4 sections. So I ended up only drawing 3 lines, because 1, 2, 3, 4. I didn't put 4 lines. If I had done that, I would have had too many. And now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 24. Perfect. And up top, 1, 2, 3, 4, 5, 6, 7, 8. So we have proven that 2/6 is equal to 8/24. Now I'm going to do one problem from your independent work, and then you're going to go and finish the rest on your own. So your first problem wants you to find the missing number, and it gives you an area model to help you out. You have 1/4 and 2 over something. So this is our missing number. And then we have our area model where we have 1 out of 4. Well, the first thing I'm going to notice is that 1 times 2 is 2. 1 times 2 is 2. So I want to multiply by 2. And I do that by cutting through the middle. And then I see I have my 2. 1, 2. Perfect. So what's our denominator? 1, 2, 3, 4, 5, 6, 7, 8. 8. All right, that's going to end our lesson today. You're now going to go finish your independent work on your own. And as always, have a great day.